Hello, this is the third video for this week. 6.1 mean, variance, standard deviation, the probability distribution, and expected value. And we'll go over this third slide with you. And after this slide, you should be able to complete week 7 homework part 1 on my math lab. Okay? Now I think this homework isn't too long. It's got about 12 problems. Yes, 12. So after watching this video, you should be able to try this homework. Okay? All right, let's go ahead and go over this part. So in this lesson, we're doing some calculation. We're going to find the expected value, variance, and standard deviation. But I also want to show you how we'll be able to do the same thing on Statcrunch. Okay? So it just says 11 slides, but it's going to go a little bit. It's probably going to be about 30-minute video again. All right. So the second part of 6.1, we are talking about mean, variance, and you know what standard deviation is. We're just simply going to find the variance and take the square root of that variance, and that's going to be called standard deviation. And we'll also learn something called expected value, which is just mean. Let's start with the mean of discrete probability distribution. You know, in statistics class, these symbols and for the formulas just look so intimidating, but you do know these symbols. You know this mu stands for the mean. So the mean of the probability distribution is going to be, what does this sigma or this symbol mean? This means sum, right? You're going to add up a whole bunch of x times p of x. And that means x being your, we'll see this in a table. It's very simple. It's not that complicated. You're just going to have to multiply x by its probability and just add them all up together. And that's how you find the mean of a discrete probability distribution. Let's read this. Each value of x is multiplied by its corresponding probability, and the products are added. That's how you find it. So here we go. I have my first example from that same example of the personality inventory test. Remember where they could score 1 for being very passive, and 5 being very aggressive, and 3 being just neither. So the probabilities are still the same: 0.16, 0.22, 0.28, 0.20, 0.14. They all add up to 1. We checked that in our last video. Let's find the mean of this probability distribution. So what do you do first? You're going to multiply x by its probability. So the first one, we'll be doing 1 times 0.16. Multiply x by its probability. So that's going to be 0.16. The next one is going to be 2 times 0.22. So we'll get 0.44. Next one, 3 times 0.28. Get 0.84. 4 times 0.20, 0.80, and lastly, we will do 5 times 0.14, and that gives you 0.70. Now, after finding all these products, we are going to just simply add them all. So on your calculator, do add 0.16 plus 0.44, plus 0.84, plus 0.8, and 0.7. If you add them all together, you should get 2.94, and that is the mean of this probability distribution. That's how you find it, really. Find a whole bunch of products, and those products are simply x times its corresponding probability. Add them all up together, and that's how you find the mean of a probability distribution. All right, now expected value of a discrete random variable is the mean of the random variable. So look at the new notation. Mu equals this part, what I'm pointing at right there, that's what we just did. And that's also called expected value. Look, E of x, the expected value of this random variable is exactly the same thing as the mean of this random variable. So let's try to find one. And now this one is the word problem, and I didn't give you a table, so we're going to fill out the table together. Take a look at a raffle. 1,500 tickets are sold at $2 each for 4 prizes of $500, $250, $150, and $75. So how many tickets are winning tickets? Only 4, right? There are only 4 winning tickets out of 1,500 tickets. So how many are losing tickets? So if you do 1,500 minus 4, there are 1,496 losing tickets. And, it's probably more likely that we're going to buy one that is a loser ticket, but who knows, maybe we'll win one of these expensive price tickets. But say that we buy just one ticket. Let's find the expected value and let's talk about what that means. Okay, now listen though, say that you won $500. You were that lucky one and you won that $500. How much did you just gain? Now remember, you spent $2, right, to buy this one ticket. So even though you got $500, you really only got $498 because you have to subtract the money that you spent to buy that ticket. So take a look. My X, the one that I just talked about, 498. In case you win that best the price of 500, because you still spent $2 to enter this game, you have to do 500 minus 2. So that's how we got 498. Now, say that you won $250 price. Well, remember you spent $2 to buy that ticket, so how much is your gain? It's really $248, right? Now, what I'm doing to get these X values is I'm just subtracting 2 from these prices. Now, what about $150? $150, in order for you to win that money, you need to spend $2. So you ended up really gaining $148. And the last winning ticket, the $75 one, you're gonna be going home with $73 extra in your pocket. Now though, many of us are going to be the losers of this raffle. Well, how much is your gain if you didn't win any of these 4 prizes? You would like to think it's 0, but remember we just spent $2 to buy that losing ticket. So the last one, I'm sorry, it's going to be negative $2. So now, let's talk about the probability of these corresponding net gains, or the money that you're going home with. Probability of winning that first ticket is going to be 1 out of 1,500, right? Same thing. They only put 1 of each winning ticket, so the first 4 are going to be just 1 out of 1,500. Now, what about the losing tickets? How many tickets don't come with any prizes? Now, remember, we got that from doing 1,500 minus 4. Therefore, 1,496 tickets are gonna be the cases that you will lose $2. So these are the probabilities. Now, let's find the expected value. Okay. Now remember, in order for us to find those expected values, we simply multiply x by its corresponding probability. And I'm just gonna keep my fractions not simplified. I did 498 times 1 over 1,500. The next one will be 284 times 1 over 1,500. Just like that, we multiply. But take a look at the very last one. We are multiplying negative $2 by 1,496 over 1,500. So the last fraction came out to be negative 2,992 over 1,500. Now look, compared to these positive numbers, positive, 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 this is a big negative number. So what I want you to try is, and I'll show you, you know what, yeah, do add them, and I added them before to make these just to slides. When I added all these fractions together, guess what I got? I got negative 2025 over 1,500. And if I divide negative 2,025 by 1,500, guess what we got? We got negative $1.35. Look, the expected value of this raffle came out to be negative $1.35. Now let me go back. What does that mean? Because they wanted us to interpret its meaning. Every time you're playing this raffle, you are expected to lose $1.35. Okay? So say that you are that crazy one and you are playing this raffle 10 times. Multiply this negative 1.35 times 10. If you play this raffle 10 times, you are expected to lose $13.50. Now, one of the math problems that are the My Math Lab homework problem that you are going to do after this section is is on this fair game, or this one isn't a fair game, right? Because to be a fair game, the expected value should come out to be 0. You should keep on playing, and you shouldn't really lose or gain any money. But this one, if you keep on playing, you will lose $1.35 every time. Okay? But who knows? Maybe you're extremely lucky and get one of these 4 winning tickets. All right. Let's try this one. Rolling one die. We looked at this example in our previous video. And we roll a die, but we're going to square the number that we see. So if you get, let's say, a random example, say that you rolled 4. You're going to square 4 and get 16. So 4 times 4, 16. But then the chances, the probability of seeing these numbers are just going to be 1 out of 6 for each of these, right? For a fair die. Compute the expected value of this. And you can do this in a single line. You don't have to really create a big table to do it. All you're going to do is you're going to do 1 times 1 over 6 plus 4 times 1 over 6 plus 9 times 1 over 6 and so on. So if you do that, the expected value, the average, now listen, it doesn't have to come out to be a whole number. Notice the expected value came out to be a decimal, 15.17, because it is the average that we are expecting when we keep on doing this. So that's that. That's an example of expected value. Now let's talk about something that's a little more complicated. Now listen, though, we're going to do all of these in Statcrunch. So I know you can do these by hand now, at least the expected value, because that one isn't too complicated. It's just about multiplying and adding, multiplying and adding. But variance and standard deviation, it does get a little too complicated to do by hand. And it's really not that efficient if you do every one of these by hand, you know. So here is the formula, though. That is the formula for variance. Now look, it involves subtracting the mu. What does mu stand for? This is the mean, right? So if you want to find the variance, you better have the expected value or the mean ready, okay? Because you will be subtracting those values from x. You'll be squaring them, and then you need to multiply that by the probability of that corresponding x. And then for the last part, you will add them all. Now that sounds very complicated, but we will do this in a very nice organized table together. Now take a look. That very same passive-aggressive trade inventory test. Let's find the variance. Now this is where we stopped for the, what's it called, mean of the distribution. We found that the mean was 2.94, right? Take a look. We did all that work before, and we got the mean to be 2.94. We're going to continue filling out the rest of this big table to calculate the variance by hand. Now, to find the variance, you will have to subtract that mean that we just found from each of these x values, and you have to square them. So what you will do for the first one is you will do 1 minus, I boxed them in red, right? 1 minus the mean of 2.94, and you will square it. If you do that, 1 minus 2.94 squared will give you 3.7636. I used my little scientific calculator to find all these. What do you think the next one will be? You have to do 2 minus 2.94, and you square that, and that will come out to be 0.8836. The next one should be 3 minus 2.94, and you have to square that value. One of the questions that you answered for me on test 1 was which one of these values never come out to be negative, and the answer was standard deviation or variance, because take a look, we're squaring all these, we're getting rid of these negative signs. All right, next box, 4 minus 2.94, and if you square that, you will get 1.1236. The last one, 5 minus 2.94, if you square that, you will get 4.2436. Now, this is time for us to multiply these values that we just got. We're going to multiply these values that we just got by the probability, okay? So the two boxes that the purple boxes, we're going to multiply 3.7636 by 0.16. And that came out to be 0.602176. And as you can see, I didn't want to round it in the middle of a problem, so I just typed up, or I wrote down a long decimal. Now, the thing is, the math isn't too complicated here, right? It's just subtracting and multiplying and adding up. But just because we have, only 5 data points, and only with these 5, we're doing so many different calculations. So it does look a little confusing, but I hope you are following. The next one I'm going to do, this number that we just found times the probability 0.22. So 0.836 times 0.22, that came out to be this decimal. All right, I continue that. I found the rest of them, guys. Toop, 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 toop. All right, take a look. After finding all the products, guess what we do to find the variance? The last thing that we do is just simply add these all up together. So if you add up this 0.6, 0.19, 0.001, 0.22, 0.59, you will get 1.6164. See, that's how we find the variance by hand. And you know, that was a lot. But listen, you can do it if you want to, okay? But now let's talk about standard deviation, okay? So remember, variance just came out to be 1.6164, right? To go down to standard deviation, remember, we simply take the square root of that number. So standard deviation is going to be square root of 1.6164, and it comes out to be 1.2714. That's a lot of calculation that we did by hand on tables, but now I'm going to show you all these. Let's actually do the same exact example. This time, let's try this on Statcrunch, okay? Because I really don't expect you to do all these by hand when you're doing those homework problems. I'm sure, and I checked earlier that you can send the data straight to Statcrunch from my stat lab, and you can use that tool. I just need to show you. I need to teach you how to do that on Statcrunch. So let's go ahead and do that, okay? And that's it for my slides for this. But now, please watch. Continue to watch because you're about to learn how to do this in Statcrunch. Now, let's go to Statcrunch. I was logged in here before, but you will need to go to Canvas. Yeah, why not? Let's do that together. You go to My Labs and Mastering. My Lab and Mastering. Open My Lab and Mastering. And let's open Statcrunch. My goal is to show you how to find the mean, standard deviation on Statcrunch, okay, without having that big table. So open Statcrunch, let's enter the data that we just used, okay? What was it? I think, the personality trait one, right? So the inputs were, I'm sorry, not inputs. The results of that personality trait test was 1, 2, 3, 4, 5. Now let me zoom in a little bit so that, can I zoom in? I wonder. Oh yes, why not? I can zoom in. Enter 1, 2, 3, 4, 5 there. But what were the probabilities? I forgot. Let me go back to my slide. The probabilities, I'm writing them down on my piece of paper real quick so that I can type these in my screen. No, I want to see if I want to have 2 computers. You know, my husband works with 2 computer screen when he's working. Oh, if I have 2 computer monitor, I don't have to jump back and forth. Anyways, all right, so here are the probabilities: 0.16, 0.22, oopsies, 0.22, 0.28, 0.20, and 0.14. Okay, enter them all. You ready? Are you still with me? If you're not with me, you know you can stop the video, right? Okay, let's go ahead and find the mean and, guys, why not? It doesn't matter, but I'm gonna go ahead and label my columns. Okay, so let's go ahead and find the probability distribution. Okay, so what do you have to do? You have to go to Stat. Okay, go to Stat. Go to Calculators. Oh, I was zoomed in too much. You with me? Go to Stat, go to Calculators, and go all the way down, please. Go down to Custom. Go all the way down to Custom. I hope you're watching this video, right? All right, go down to Custom, click it. Now, let's go ahead and select our variables. This is how you can do it. Values in X or var1. variable 1, and the weights. Remember, the weights are the probability, or the p of x, or variable 2 if you didn't change the name. And then simply click compute. And there we go. Oh, zoom out, zoom out. Now remember the mean and the standard deviation that we calculated by hand. I'm going to go ahead and take a screenshot of this. And then compare this on my slide, okay? This is what we got from Statcrunch. I'm going to go ahead and just bring this over here. So much stuff over here. So just, oh, my dogs are snoring, guys. Alrighty, I just brought this table over here so that we can compare the answers that we got from Statcrunch. Now let's take a look. By hand, we got the mean, the expected value to be 2.94, right? We got the mean to be 2.94, and on Statcrunch, we again got 2.94. So the mean was great. And now what about standard deviation? Standard deviation, oopsie, I have to click this 2 more times. Standard deviation, we found the variance first and we took square root of that and got 1.27, right? And that is the same thing as what Statcrunch gave me. So it's up to you. You can use Statcrunch. I think you will, because I think it's just easier, isn't it? But you will, hopefully you are watching what's going on. But that's how you will do it. I'm gonna go ahead and delete this. Or maybe I will just stick this on my other slide so that people can see the result over here. And I'll call it from Statcrunch. Many of the homework problems that you will do for this section, you will have to find the mean and the standard deviation, and I suggest you do it this way, okay? And that's really it for 6.1. We talked about mean, standard deviation, variance, and expected value in this video. I want you to practice these problems on your My Math Lab homework. And since this was another about 25-minute video, I will come back and continue with binomial distribution. So this week I'm uploading I'm teaching a couple short lessons, about 4 short lessons instead of, well, because our class is, usually 3 hours, right? All right, I'll be back later with my last video for the day, okay? Thank you.